Cool. So, what we're going to be doing today is we're going to review the thing we talked about, Sprites, which is a class that is in Pygame that helps us add entities to the game. Okay, so player bullets, tools, enemies, blocks even. Usually those are all sprites. And then we also go into physics and collisions, which will be another step in for most games, unless you're making a text-based game. Right, so sprites. Sprite is a built-in Pygame class, and it has a rectangle and an image. You have to define those two, so you need your, I guess it doesn't show here, but you need self.image, self.rectangle, and that allows the Pygame to draw your sprite with the sprite.draw. So you use I guess it would be fairies.draw. If you don't have your rectangle, Pygame won't know where to put the image. If you don't have the image, well, obviously it won't know what to draw. Okay, physics are... I think I'm going to go over this pretty quickly because not all of you will actually be using physics, or, well, it depends, to different extents. So I think you can come back, you can reference the slides as you need, but really it's just about, it's mostly jumping. Physics, the physics part is mostly jumping, and collisions as well. It's actually, there's a few things that you kind of have to mess around with to make the collisions look smooth. Otherwise, you can glitch through walls and stuff. But okay, first of all, physics, right? And really, all it means is to make the usually, especially I guess jumping is the best example of this, because usually most people don't add balls that bounce around all over the screen. So really, you just have acceleration and you have velocity, right? So velocity is your speed at which the ball is traveling, and acceleration is how fast your ball is. Well, it's acceleration, okay? So how much the speed of your ball is increasing. In this, so usually you represent acceleration as a variable, and you just add this variable to the speed variable. And usually I would recommend setting a maximum velocity. So that's the car starts slow and it speeds up and finally it's traveling at max speed, right? So that's your physics. And brings us to our first quick question. Also remember that positive numbers, oh dear. If you have a positive acceleration, the ball speeds up. If you have a negative acceleration, the ball slows down until eventually okay, that's not true. Sorry. Positive acceleration is nudging first of all, your velocity, right? If your velocity is positive, let's say your y velocity in this case, then it's going to go toward the bottom of the screen. And if your velocity is negative, it starts going to the top. And so your acceleration, which you could call, in this case, gravity, is the acceleration variable. You just keep adding that. So you can think, if the ball's already moving down and you add a negative number, then it'll slow it down until eventually it stops and it reverses direction and starts going up. At which point, you adding a negative acceleration would actually make the ball speed up going upward. So it depends on acceleration affects the ball depending on which way it's already going, right? Okay, so your question, yeah. Basically, there's some stuff. There's some code. Someone wants to implement acceleration. They have the gravity variable, but right now, all they're doing is they're moving the ball by a constant speed. Cool. Okay. Oh, this was no, so it wasn't a multiple choice. Well, how are we gonna assess this? Okay, I'll go and assess it later. But oh. Okay. Try to. Okay, I guess we should change this to multiple choice as well. But I guess if there's another written response, just try to type it. I don't know. I'm just thinking. Try and like keep it more concise. I would say. Okay. Okay. Anyways, I would say the easiest way to do this is you just say add a new line of code of. Oops. That's really all you need. I guess I'll explain this more with an example in the following slides. Yeah, so remember that y-axis means you're going, if you have a positive y number, you're going downward. It's just how computers are coded. I don't remember. I believe back when the TVs first came out, you might have to look this up to verify, but I'm pretty sure when TVs first came out, they started by like beaming stuff into the top left corner, so that's why it's 0, something like that. Anyways, back to Pygame, right? So the way jumping works is you have gravity is just always, it's basically we're mimicking real life physics, right? So gravity pushes down on us constantly, keeps us in the ground. But jumping gives you like a temporary negative y velocity, which will bring the character up. So as soon as we press the space key, we set the y speed to this negative number. And so Mario is going to start jumping, but each frame, the y speed is decreased. Well, okay, this is extreme gravity. So in this case, we jump after one frame, Mario gets up to here, but now Mario's not going to travel as much because the gravity has decreased their upward momentum. And eventually you reach here, the top of the jump, at which point gravity starts like making Mario go back down faster. So that's how jumping works. Hopefully that made sense. If not, I would say you can play around with the code to kind of get more of a sense of this. But basically, the characters, whenever you want to simulate real life jumping, I guess it's hard to tell as a human jumping up and down, but to make it look like more animated, usually it starts going up fast, but then toward the end of the jump, the character slows down. But if you have like a small jump in your game, whether they only jump up like one block or something, then this is less noticeable. But for with larger jumps, then your character's gonna like hover longer in the air, especially at the top, because of the. Anyways, cool. Now, okay. Basically, what we want you to do is whatever. You can use the bird if you want. It's just a bonus. We want you to make a box that jumps. So, also like a tip is you might want to set like a collision with the floor. Well, this is a bonus technically, but you might just want to do that so your code's easier because every time, otherwise the character is just going to fall off the screen and then you will have to restart the code to test it more. So yeah, basically have some key that you press, and it'll set your y momentum, not y momentum. It'll set your y speed to like say -10 or whatever. But then you also have gravity that's just constantly pulling it down. So if you don't do anything, the bird or whatever your thing is, it just drops all the way to the floor. And oh yeah, bonus number 3, you can add terminal velocity, so it doesn't like accelerate beyond. Actually, yeah. Okay. And what else? Yeah, we'll do 15 minutes for this one. Yeah, it shouldn't be too hard. In terms of your code, should be able to. Okay, just use the template file from last time. It's somewhere. It's somewhere here. I'll send it in the chat in a moment. Um, where is the template file? So sad. You can use code. You can use code from a previous exercise if you want. It's not really much of an yeah. Okay. Actually, we'll do 20 minutes because the slides. Once upon a time, someone suggested that we use 20 minutes for this exercise, so we're going to use 20 minutes. You just use whatever code you want. It literally, like if you use your exercise code from before, that'll probably help you because then you have a rectangle to play with. And yeah. Just join your. Okay. Next up. Also, if you didn't finish this, you can resume it in the next breakout room. Make sure you ask your mentor if you've been stuck for. If you haven't figured it out yet, it's probably a good idea to ask your mentor. Okay, first collisions. Okay, what's a collision? Collision is when sprites overlap. That's a coding term, but you know, it's pretty intuitive. It is what it sounds like. But if you want an official term, it's when like the rectangles of the usually we use rectangles because they're easier to calculate. When some rectangle is overlapping with another rectangle. And the number one use case for this is obviously when you have oh look, is like stopping a player from moving. Well, clearly this. Okay, whatever. And so we'll get into that a little later. But the simple way, if you just want to see if two things have collided, then there's a built-in function that you can say have the rectangles of this. Remember how every sprite has a self.rect. What's it called? Attribute. Yeah. So we use this and it's just saying is the self.rect attribute like overlapping, right? And so the code behind this is really just a bunch of if else statements that check the borders of the rectangle. I think you can probably find an example online if you want, but it's not really. You can do it with pure logic, and that's really what this thing does. But it's like it's built in, so it makes it easier, right? And just gives you a true or false. So for example, a very simple way to do this, which clearly won't work for a more complex game, but if you only have like one platform and no player's dropping, you say, okay, the moment they collect, I set the y speed to 0. Boom. Okay. And this check, usually I do collision checks in the player's update function. If it's something the player is going to collide with, then I'll probably it'll be like, okay, if player collides with enemy, or okay, player collides with block, player collides with bullets. Like I do the checks in the update function of the player class, but so I would say for any entity that has like HP or is a kind of like a mob in Minecraft. Well, it's not the greatest analogy, but it's something that usually like moves around, or you can interact. Okay. But I would say try and group the update functions in like one or two classes, like the important stuff. So like enemy and player sprites, you push just have most of the updates in there. And so the way it works is if you have like an item or like a power up that you want your player to collect, you would check for the collision in the player class. You say if players collide with power up, give player the power up, and then for the power up, you just delete it. So you don't do like the thing is you could do it both ways. I don't recommend the other way, but it's because then it's just harder to keep track of the updates if you are like for every single different power up in the game, let's like write a different update function there. Um, so the other way to do it is you could check for the collision in the update function of the power up, where it would be like in the power up it says if power up has collided with player, grants effect to player. Because like either way you can well you will there's oh I wonder if we'll cover this later. But basically, for example, when I'm creating a player class, I can pass in. Well, there actually no, you wouldn't need to do this. But yeah, as long as you're like, okay, here's player and here's like power up, then you can have an interaction between the two, and it doesn't really matter where you want. You put the updates. Like you can make it work regardless of where you put the effect in, because um, okay, actually, this is sorry. This is okay. I must be confusing you guys because this is just the if statement. But if I put like this sort of if statements in like, I could choose to put this in the player class, or I could put it into the platform. In which case, what am I trying to say? You know what? Forget what I said. I think I'm not adding any value like this. But yeah, I usually put all the checks in the update class of like player and then maybe enemy, but like the main stuff. I wouldn't put it into like less important classes. And here's a question: if the enemy in the wall are sprites, what does the code do? Like if this is also written response, just keep it concise. It really doesn't take that long. Should be, yeah. Hmm. Also, Jahan, can you share like the top hat thing with? Wait, no, never mind. I can log in myself, but I'll check.
Yeah, so this one's short answer also.
Yeah, keep it short, guys. I don't know why it's short answer, but this is from last session. I didn't change anything. I think it was short answer last session as well. Not last session, sorry, last semester. Keep it concise, guys. Okay. Yeah, so this one is essentially enemy hits the wall. Okay, let me share screen. Blah. This is right. No, wrong tab. Boom. So yeah, this is like if you have a dude, this dude over here. Let's move. Oh, that's not a good idea. You know what? This guy. Okay. It's like the logic over in the code is saying if the enemy and the wall have collided. So let's just say this guy's an enemy, touches the platform, boom, that's true now. The statement is true. What do? Do you multiply the speed by -1, which basically makes it switch direction. So they're going this way continuously. And that's that. Yeah, this is shorthand. Well, you should probably, the same as like plus equals, right? That's the easiest way to change the direction. Yeah, there's a comment as well. Okay, and finally, if you want to check for multiple collisions, you use a for loop. Let me share the screen. I am sharing. Okay, that's good. For loop, for loop. Simple, pretty simple. And so for now, you can put this code just in the update section of the entire game loop. But I would say for games, especially if you're gonna like add more layers, these sorts of collision checks should go into the player classes update function. Okay, now if you want to delete sprites, you use sprite.kill. So basically, it's the actual name of the sprite. If your player is called, if you created some object called like Bob equals player somewhere, then you would say bob.kill, kill Bob. Well, in this case, you're actually checking for, yeah, never mind. Okay. All right, here's a question for y'all to ponder. Anyways, what happened here? No. Okay. I swear, I added like ignite points to this thing like a moment ago, and now it's gone. Okay. Here's what we did, right? We go, boom. Oh, that's funny. It's 50, guys. It's 50 points. All right, so the exercise is just to, you can use your code from session 4. And, well, assuming your code from session 4 actually works, then you can use it. And what you want to do is to make it so that the player's Y velocity is 0 when it touches platform. Also, like, if you guys want to implement platform within multiple directions, oops, there you go. There you go. Okay, so especially if once you finish this exercise, what I recommend checking out is one of these two YouTube videos here, and basically it's for collision in all 4 directions. And so the reason, like right now, you may have noticed, like the reason it's simple because all we have to do is set the player's Y velocity to 0. But if the player collides from some random direction, how do you know like what to set to 0? And you could try and figure it out yourself. So maybe you take a shot at that before you look at the videos. But these two YouTube video here in the comments, or not, sorry, the speaker notes of the final slide, I definitely recommend checking out. I looked at both of them. Well, I actually found them. And they basically give you, I think, 2 different approaches that you can use for 4-directional collision, and you're quite likely to use it in your game, so you might as well go check that out. And as for the bonuses, like you can add the bonuses, or you can just decide, okay, I'm gonna implement 4-directional collision, or you can do all of it. So yeah.